Hello everyone, this is Aravind Seshadri from Roll-to-Roll Technologies. Today we're going to touch briefly about our actuator settings. How do we set different parameters on the actuator on our SCU5? All of our SCU5 controllers have the ability to connect to a variety of different actuators that are driven by stepper motors. We provide our own drivers for it. If you look at our documentation, you can see that from the SCU5 controller, we go to a motor driver through the motor communication cable. And from the motor driver, we go to the actuator through the actuator cable. Because we have the flexibility to connect multiple different types of actuators, we also provide the ability to set up some of the parameters of the actuator through our SCU5 controller. And that's what we're going to look at today. And we're going to see how to set the stroke of the actuator, the pitch of the actuator, the speed, the polarity, and so on and so forth. We do have one of our actuator connected right now to the SCU5 controller, and that's the one right here. And this is our standard upgrade kit actuator, and this one has a front spherical eye and a rear spherical eye, and then it has bearings supporting the actuator to extend and retract. And this is our LHS series with a 4-inch stroke. This actuator also has a servo center sensor that is installed right here, and that's actually looking at the rail that is going in and out. The servo center basically allows us to quickly center the actuator or home the actuator to a position which makes the web guide be parallel to the other rollers within the machine. We'll also go through that in another video, but essentially we have our actuator connected here, and then if you use our SCU5 controller to move the actuator, you can see that the actuator is moving back and forth, and that's also seen on this bar graph right there. So we'll take a look at how we're going to set some of the parameters. That can be done by going into the tools icon and then power user and then actuator, and this provides you with some of the settings that are currently available. And this shows a pitch of 0.25 inch, a stroke of 1.38 inch. There's also a motor polarity setting here, and then the speed and the acceleration. When we ship our controller, based on the actuator that is purchased, we preset those values in the controller and ship it. But if you want to change it, it's pretty simple. So for example, if I want to change the speed, I can just drag this right there and set the speed. And we can also change the acceleration. The speed and the acceleration can be changed independently. And the pitch of the actuator is depending upon what the actuator is, and that is basically one revolution of the motor. How much is the actuator going to extend or retract? In our case, this particular actuator has a pitch of 0.25 inches, and that's what it is set up there. If you need to change the pitch, you can just press this button and it's going to increment or decrement the pitch. The units right now is shown is in inches, and if you want to see those units in millimeters, you can go to this screen, hit the operator icon, hit the display, and change the units to millimeters. And once you do that, you can go back to the power user, actuator, and you can see that the actuator units are now in millimeters. This is about 6.5 or 0.25 inch approximately, and then the stroke is 35 millimeters, and you can probably set it to the stroke on the actuator. The stroke that you set is not the actual mechanical stroke that is available on the actuator. This is just an electronic limit. In order to avoid some of the pitfalls with some of the other actuators that are available, where if there's issue, let's say the web breaks, the actuator may go to one side, and it might keep driving because it has reached this limit. It doesn't know it has reached this limit, and it keeps driving it, and that might burn out the actuator. To prevent that from happening, in our case, we actually have an electronic limit. That means that if the actuator reaches its electronic limit, whether there is a mechanical limit or not, it will stop. Just to show you how that works, I'm going to set the stroke to be some really small number, let's say 30 millimeters. And if I go back to the home screen and I try to jog the actuator, you can see that it's going in, and right now the actuator position it's showing that it has reached its fully retracted limit. even though if you look at this actuator, there's a lot of stroke remaining. So if you look at here, There's still a lot of room for the actuator to retract more, but it stopped at this electronic limit just to prevent it from burning or destroying the motor. So the electronic limit can be any limit that you set, and that limit of whatever that the stroke that I showed, again, if I go back to the screen and to the actuator, you can see that the 30, what that 30 means is that it's going to be 15 from the middle of the actuator position and on one side, and then 15 on the other side, and that's what the stroke means. So if you are in the middle position of the actuator, you can go 15 on one side and 15 on the other side. That's what the stroke means in terms of setting. There's also the polarity. So what we can do is we can change the polarity, and if you remember when I did this, when I pressed the plus, it was going in a certain direction, and if I do this, when I press the plus, it's actually extending. In the previous case, when I pressed the plus, it was actually retracting. And that's also shown here in this position. When the polarity is the standard polarity, the plus will increase the actuator position, and that's what this is showing, and the negative will decrease the actuator position, so it's retracting. If we reverse the polarity, then it will do the opposite. And again, when we reverse the polarity, that it clearly shows here. Now if you press the plus, it's extending, retracting, and then if you do the minus, it's actually extending. So the polarity can be changed. As I'm jogging the actuator back and forth, one of the things that you can notice is that this bar graph changes color, and right now it's in yellow or amber, and then if I go to another limit, and now it becomes red. This is more evident in the other direction. So if I go all the way in the other direction, this is going to be yellow, and then if I go reach a certain, it goes to red. This is a quick visual indication for the operator to know that the actuator is close to its extreme position, if not at the extreme position. If it's in red, it's within 10% of the extreme position limit, and if it is in yellow, then it's between 20% to 30% of the extreme limit. So we don't typically like to run the webguide in this position, is that there's not enough room for correction in this direction. So if there is an error in this direction and the actuator needs to move that way, there's not enough room to correct for it. So anyway, a quick visual indication for us to see where the actuator is. Again, if you want to see that in a bigger screen, if you just click on that motor icon, then you can see that. The same bar graph that you saw on the home screen, that's essentially the things with regard to the stroke and the pitch and the speed and the polarity. Again, just to reiterate, there is a difference between the mechanical limits and the electronic limits. The mechanical limits are the actuator cannot move anymore because it's mechanically inhibited, and we never want to set that actuator or install the actuator in that scenario where the mechanical limits are reached. The electronic limits are just safety limits, and this allows us to stop the actuator from moving even before it reaches the mechanical limits. So we typically suggest that you install the actuator, move it back and forth, find the home position, set the home position or the servo center position, and then set a certain stroke, and then jog all the way to one side, make sure that it doesn't hit the mechanical limits, and jog all the way to the other side and make sure that it doesn't hit the mechanical limits. And as long as it doesn't, then the electronic limits are fine. If in any scenario, whether you're going jogging left or jogging right, it hits the mechanical limits, then you would have to reduce the electronic limits, so we never get into that situation where the actuator might hit the mechanical. That's all we need to do in terms of setting up the actuator in terms of the stroke and the pitch. There are other few functionalities that are available for certain controllers. For example, the actuator position, if it reaches the extreme position, there is a way for us to set digital outputs so that not just an operator needs to look at it, but the digital output can provide a signal to the PLC to alert the PLC that, hey, the actuator has reached this limit. The other option that we have, this is mainly for our big actuators that are moving the unwinds and rewinds, which are susceptible to damage if we reach the mechanical limit, that we can add additional limit switches, either mechanical limit switches or even electronic limit switches, make sure that the mechanical limits are never reached. And if we have that option, if we have the hardware provided with your actuator, then you have the ability to enable them. The way to do that is to get into the tools and then the power user, and then in the controller there's this limit switches icon button, and then we just need to turn on the limit switches. If you don't have the limit switches and you turn on the limit switches, the actuator might not move. Just be aware of that. But if you do have the limit switches and you want to enable that functionality, then you can enable that functionality by turning on the limit switch. So those are the basics of the actuator settings in terms of stroke, pitch, polarity, limits, and limit switches. In a subsequent video, we'll talk about the servo center functionalities, but in the meantime, do subscribe to our channel, and we'll see you in the next video.